Welcome my dear students. In this video we will discuss classification of signals. Full course videos and their PPTs are available at drsatvi.in. The link is given in the description. Now let us start with the topic classification of signals. Signals can be anything that conveys information, for example picture, speech or video etc. To design and analyze engineering systems, understanding of electrical and electromagnetic signals is important for engineers. These signals can be classified in many different ways depending upon their nature. Depending upon the nature of the independent variable and dependent variables, they can be classified as continuous time, discrete time, and digital signals. We can estimate the value of the amplitude of the signal at any point of time, then they are called deterministic signal. Otherwise, they can be classified as random signals or non-deterministic signals. Depending upon the number of the independent parameters involved in the signal, they can be classified as one-dimensional or multi-dimensional signals. For example, picture is a two-dimensional signal and speech is a one-dimensional signal. Based on the causality, signals can also be classified as causal, anti-causal or non-causal signals. Depending upon the periodicity of the signals, they can be classified as periodic and aperiodic signals. If the signal repeats after a particular interval of time, then signals are called periodic signals. Depending upon the symmetrical nature of the signals, they can also be classified as even signals and odd signals. Depending upon the energy contents of the signal, signals can also be classified as energy signals or power signals. For better understanding, now let us discuss all these classification approaches one by one. Depending upon the nature of the independent and dependent variables, signals can be classified as continuous time, discrete time, and digital signals. In continuous time signals, the independent parameter and dependent parameter do have real number values. That means there are infinite possible values of xt corresponding to infinite possible instances of time t. Continuous time signals, those cannot be modeled mathematically, are impossible to be handled with computers, as it requires infinite memory to store such signals. Continuous time signal, when sampled at equal intervals of time t, is called a discrete time signal, which is represented as xnt or simply xn, where n can have all integer values from -infinity to +infinity. As per sampling theorem, the continuous time signal can be recovered from its sampled signals when the sampling is done at a frequency fs that is greater than or equal to twice the maximum frequency of the continuous time signal. It is important to note here that xn still can have infinite possible values. When amplitude is also discretized, as shown in the third figure, and the sample values are rounded off to the nearest discrete level, they are called quantized signals. When such quantized signals are coded using binary numbers as shown in this figure, then the signal is called digital signal. Since the amplitude in continuous time signal xt and discrete time signal xn can have infinite possible values, therefore are termed as analog signals, whereas binary coded quantized signals are called digital signals. The next approach of classification is based on the determinability of the signals. A signal is classified as a deterministic signal if its amplitude can be calculated at any point of time. A deterministic signal can normally be expressed using mathematical function of independent variable. For example, xt as shown in this figure can be written as a sine of omega t plus phi. A signal whose amplitude cannot be predicted at any point of time is classified as a random signal. A random signal can only be expressed using the function of probability-based variables. As shown in this figure, we cannot make any formula of this, but we can express it using probability functions. The examples of random signals are speech and noise signal. The next approach of classification of signal is based on the number of independent parameters. A signal which is a function of only single independent variable is called a one-dimensional signal. For example, speech and heartbeat signal are one-dimensional signals because there is only one independent parameter, that is time. A signal which is a function of two or more independent variables is called multi-dimensional signal. For example, a photograph is a two-dimensional signal as shown in this figure. There are x and y parameters. Motion picture of a black and white TV is a 3D signal in which third parameter is time. Signals can also be classified on the basis of the causality of the signals. The term causality is usually used to characterize systems. However, on the same line, signals can also be classified as causal or non-causal or anti-causal signals. A signal xt is a causal signal when its magnitude is greater than 0 for the time greater than equal to 0. A signal is classified as a causal signal when its magnitude is greater than 0 for the time less than 0. A signal is classified as a non-causal signal when the magnitude is greater than 0 for the time t less than and equal to or greater than 0. Signals can be classified as even signal and odd signal on the basis of the symmetrical nature of the signals. A signal xt is said to be an even signal if xt is equal to x of minus t. As shown in this figure, if we put t as minus t in this signal, we will get the same signal and the signal is called even signal. For the discrete time even signal, xn is equal to x of minus n. A signal xt is termed as odd signal if xt is equal to minus x, a function of minus t. As shown in this figure, if we replace t with minus t, the signal is flipped along the vertical axis and horizontal axis. And the signal is called odd signal. For the discrete time odd signal, xn is equal to minus x function of minus n. Signals can be classified as a periodic signal or aperiodic signals on the basis of the periodicity of the signals. A signal xt is said to be a periodic signal if it repeats after a finite time interval of t naught. Mathematically, xt is equal to xt plus t naught, where t naught is the fundamental time period of the signal and f naught, that is equal to 1 upon t naught, is called the fundamental frequency of the signal. The square wave shown in this figure and the sinusoidal shown in this figure are called periodic signals because they repeat after an interval of t naught. A signal is called aperiodic signal or non-periodic signal if it repeats after infinity time, or in other words, it never repeats afterwards. An example of non-periodic signal is shown in this third figure. Signals can be classified as energy signal or power signal on the basis of the energy contents in the signal. Energy in a continuous time signal xt is given as Ex is equal to integral from minus infinity to plus infinity x square t mod dt. If the energy content Ex is greater than 0 and less than infinity, then signal is termed as a energy signal. If the energy of the signal is infinite, then we consider its average power given as Px is equal to 1 upon 2t integral from minus t to plus t x square mod dt when capital T tends to infinity. If the average power Px is greater than 0 and less than infinity, then signal is termed as a power signal. There are signals which are neither energy nor power signal. We will discuss such signals in our next video. Let us now conclude this video with some questions from examination point of view. First, how signals are classified. Discuss classification of signals with suitable examples. Third, what are analog and digital signals? Fourth, what are periodic and aperiodic signals? Give examples of deterministic and random signals. Sixth, what are multidimensional signals? Give examples. And the last one is differentiate between even and odd signals. I hope you might have understood the concepts of classification of signals. Thank you, my dear students. In the next video, we will cover the topic analysis of periodic and aperiodic signals.